Hello students, today we study derivative of logarithmic function. Now, what is logarithmic differentiation? It is a process of taking natural logarithms before differentiation. Now, it helps us to use the laws of logarithm to simplify the function and differentiate easily. When can we use logarithmic differentiation? It is used if the function is product or quotient of two or more function, or the function are of the form y is equal to f of x raised to g of x. Okay, let us start with the first question. Now, we have to differentiate x minus 1 whole square upon x plus 2 whole raised to 3 into x plus 3 whole raised to 4. Now what we do, we take log on both sides. So we write log y on left hand side and log y on right hand side. Now we are using properties of logarithm. So by properties of logarithm, we write log of x minus 1 whole square minus 2 log of x plus 2 whole raised to 3 minus log of x plus 3 whole raised to 4. Now why we have minus sign here? Because these two terms are in the denominator. Again, using properties of logarithm, this 2 will come and we'll write here 2. So we have log y is equal to 2 log of x minus 1. This 3 will come here and we'll write here 3, and 4 power, it will come here and we write 4. So we have this. Now we have simplified. Now we can differentiate. So how do you differentiate? Derivative of log y is 1 upon y dy by dx, d dx of y. Now you know the derivative log x is 1 upon x. So derivative log y is 1 upon y, and again we are differentiating y, so we have d dx of y. And now we differentiate. So 2 as it is, log of x minus 1, derivative of log x is 1 upon x. So we have 1 upon x minus 1 minus 3, log of x plus 2 is 1 upon x plus 2. And obviously we differentiate x minus 1, so derivative of x is 1, 1 is 0. Here also we differentiate x plus 2, derivative of x is 1, 2 is 0. Similarly, 4 log of x plus 3 becomes 1 upon x plus 3, and derivative of x plus 3 is derivative of x is 1 and 3 is constant. Now what we do, we shift y from left hand side to right hand side. So we get dy by dx equal to y 2 upon x minus 1 minus 3 upon x plus 2 minus 4 upon x plus 3. Now what is y? It is our original function. So we replace it by the original function. So we get the required answer. Dy by dx equal to y and into 2 upon x minus 1 minus 3 upon x plus 2 minus 4 upon x plus 3. Okay. Let us go to the next question. Question number 2. We have y is equal to cube root of 4x plus 1 upon 2x plus 3 into 5 minus 2x whole square. What we do, take log on both sides. So we have log y is equal to cube root of log. Now for each term we have power 1 by 3 because it is cube root. So we have log of 4x plus 1 whole raised to 1 by 3 minus log of 2x plus 3 whole raised to 1 by 3 minus log of 5 minus 2x whole raised to 2 by 3. Now it's 2 by 3, we have 2 here and it gets multiplied. So 2 multiplied by 1 by 3. So we have 2 by 3. So we're getting 2 by 3. So these are power. So these will come down and we get this. Now we differentiate. Derivative of log y is 1 upon y dy by dx. Then 1 upon 3 is constant. Then log of 4x plus 1. So we have 1 upon 4x plus 1. And derivative of 4x plus 1, that's 4. Similarly 1 upon 3 as it is, log of 2x plus 3 we have 1 upon 2x plus 3 and derivative of 2x plus 3 is 2 minus 2 by 3, log of 5 minus 2x we have 1 upon 5 minus 2x and derivative of minus 2x is minus 2. So this minus minus will change to plus and hence we get a required answer. Question number 3, we have y is equal to sin x whole raised to x. Now, in the previous type, we have studied derivative of composite function. Now here you have variable raised to variable, that is sin x raised to x. So what we do, we take log on both sides. So you have log y is equal to log of sin x whole raised to x. So by property of logarithm, we get log y is equal to x into log of sin x. Now we have x is one function and log of sin x is another function, so we apply product rule. So x will remain as it is. We'll differentiate log of sin x. Then we keep log of sin x as it is and we differentiate x. Now what we do, we write x as it is. Now derivative of log of sin x is 1 upon sin x, and derivative of sin x is cos x. So derivative of sin x we write as cos x. Okay. Then further, plus log of sin x as it is, and derivative of x is 1. Log of sin x as it is and derivative of x is 1. Now next step, what we do, we shift y here, and what is y? Sin x whole raised to x. So we get the answer as dy by dx is sin x whole raised to x. We have here x. Cos x upon sin x is cot x. We write this as cot x, plus log of sin x as it is, derivative of x is 1, and hence we get a final answer, log sin x. Log sin x. Okay, let us go to the next question. Question number 4. We have y is equal to sine of x raised to x. Okay, now we know that derivative of sin x is cos x. So derivative of sine of x raised to x will be cos of x raised to x, and instead of x, what do we have? X raised to x. Now we have to differentiate x raised to x. Now it is not a standard function, so we take it separately. So we write let t be x raised to x. Take log on both sides. So we have log t is equal to log of x raised to x. So this implies that log t is equal to x into log x. Now we differentiate this. So derivative of log t is 1 upon t dt by dx. Remember, we are differentiating respect to x, t with respect to x. So we have dt by dx. Then x as it is by product rule, d by dx of log x, plus log x as it is, d by dx of x. So what we do, we write x as it is. Derivative of log x is 1 upon x. Then we write log x as it is, and derivative of x is 1. So what we get? 1 plus x log x. Hence the derivative of x raised to x is x raised to x into 1 plus log x. So we write in the final answer cos x, cos of x raised to x, and derivative of x raised to x is x raised to x 1 plus log x. You can remember this as a standard result because we are going to use many times in logarithmic differentiation. Question number 5. Y is equal to x raised to tan inverse x. We take log on both sides. So we have log y is equal to log x raised to tan inverse x, which we get as log y is equal to tan inverse x into log x. Now these are product of two functions, so we apply product rule. Derivative log y is 1 upon y dy by dx. We keep tan inverse x as it is, differentiate log x, then log x as it is, and differentiate tan inverse x. Now here we write tan inverse x as it is, so this is tan inverse x. Now derivative of log x, so derivative of log x is 1 by x, we write 1 by x, then plus log x as it is, log x as it is, and we differentiate tan inverse x. So derivative of tan inverse x is 1 upon 1 plus x square. Okay, now here we have y on left hand side. Y on left hand side we shift to right hand side. So when you shift, you get y here, and what is y? X tan inverse x, and we write this x or dy by dx equal to x tan inverse x into, we have tan inverse x, we have tan inverse x upon x plus log x upon 1 plus x square, and hence we get our final answer. So you see that using logarithmic differentiation we can solve complicated problem very easily. Question number 6, we have y is equal to x raised to x raised to x. It is function raised to function raised to function. Now we take log on both sides. So taking log, we have log y is equal to log of x raised to x raised to x, which implies log y is equal to x raised to x into log x. Now here we have product of two functions, x raised to x is one function and log x is another function. So we apply product rule. So x raised to x as it is, differentiate log x, then log x as it is and differentiate x raised to x. Now we have to find derivative of x raised to x, so we can't find it directly. So what we do, we write let t is equal to x raised to x, taking log on both sides, so we get log t is equal to x into log x, and differentiating on left hand side and right hand side. So log t is 1 upon t dt by dx, and here we apply product rule for x into log x, and hence we get the answer as dt by dx as x raised to x into 1 plus log x. Now what we are going to do, we are simply going to substitute here, and hence we'll get our answer. So what we do, we write x raised to x, derivative log x is 1 upon x, then log x as it is, derivative of x raised to x is x raised to x into 1 plus log x. Now this y is on left hand side, it will come on right hand side. What is y? X raised to x raised to x. Okay, and from both term we can take x raised to x common, and hence we get a final answer. And one more thing, that here we multiply that x raised to x into 1 by x plus log x into x raised to x, we multiply by 1, and we also multiply this by log x. So hence we get these three terms, first term, second term and third term, and from all of these three terms we find x raised to x common, so we remove it, and hence we get our final answer. Question number 7, we have y is equal to x into log x raised to log of log x. We take log on both sides. So taking log on both sides, we have log y is equal to log of log x into log of x log x. Now log of x log x we can further simplify as log x plus log of log x using this property, that is log of ab is log a plus log b. Now what we are doing, we are going to apply product rule. So here we have one function, that is log of log x, and this is the another function log x plus log of log x. It is a simple application of product rule and chain rule. So log of log x as it is, on left hand side log y is 1 upon y divided by dx, log of log x as it is, differentiate log x plus log of log x plus derivative of log of log x, and this function as it is. So we have log of log x as it is, derivative of log x is 1 upon x, derivative of log x is 1 upon log x, and derivative of log x is 1 upon x. So we have 1 upon x log x, and here log of log x, again the same thing, 1 upon log x, and derivative log x is x, and this function will remain as it is. Okay, further we shift y to from left hand side to right hand side, and we get the required answer. Okay, now we substitute for y, that is x log of log x, and we have this log of log x 1 upon x plus 1 upon x log x plus 1 upon x log x into log x plus log of log x. So this question appears to be difficult, but it's very easy. Okay, in question number 8 we have y is equal to log x whole raised to x minus cos x whole raised to cot x. Now this question is different from the previous 7. In previous 7 question we had single function, here we have two function and we have a difference. So here we are going to use the rule of difference, that is if you have y is equal to u minus v, then we write dy by dx equal to du by dx minus dv by dx. So what we do, we write the first function as log x whole raised to x, and we write the second function as cos x whole raised to cot x. So we take the first one, we differentiate, then we take the second function, differentiate, and then we substitute in this. So let us write this as equation number 1. So this is equation number 1. Now we take u is equal to log x whole raised to x, we take log on both sides, so you have log u is equal to log of log x whole raised to x, which implies log u is equal to x into log of log x. Now here we have product of two function, x is one function and log of log x is another function. So what we do, we apply product rule on right hand side. On left hand side we have log u is 1 upon u du by dx. So applying product rule, where we write x as it is, differentiating log of log x, which we have 1 upon log x and derivative log x is 1 upon x, then log of log x as it is and derivative of x is 1. Now u is on left hand side, we shift to right hand side. So you have du by dx is equal to u into 1 upon log x plus log of log x. Okay, now what we do, we replace this u. What is u? Log x whole raised to x. And hence we get du by dx as log x whole raised to x into 1 upon log x plus log of log x. Now we write this as equation number 2. Okay, now we'll differentiate v is equal to cos x raised to cot x. Now v is equal to cos x raised to cot x. Taking log on both sides, we have log v is equal to log of cos x raised to cot x, which implies log v is equal to cot x into log of cos x. So right hand side we have two functions. Cot x is one function and log of cos x is another function. So we apply product rule. So derivative of log v is 1 upon v dv by dx, and here we apply product rule. Cot x as it is, derivative of log of sin x is 1 upon cos x, derivative cos x is minus sin x, then log of cos x as it is, derivative cot x is minus cosec square x. Now we have minus in both, so we can take minus common. Now sin x upon cos x is tan x, cot x into tan x is 1, so we get 1 here, and we have cosec square x log of cos x. So what we do, v is on left hand side, we shift to right hand side and replace v by cos x raised to cot x. So hence we get a third equation. Okay, now what we are going to do, we are going to substitute second and third in the first one, and hence we get the required answer. Here you have minus sign and in between you have minus, so minus minus changes to plus, and this is the required answer. Okay, question number 9, we have y is equal to 10 raised to x plus x raised to x raised to 10 plus x 10 raised to x raised to 10 raised to x. So we write the first function as u, second function as v, and third function as w. So what is the question? It is addition of three functions. So we apply rule of sum. So we have dy by dx. So this should be answer. Dy by dx equal to du by dx plus dv by dx plus dw by dx. So we write this as first equation. So you're going to get this separately, okay, and then substitute in the first equation. So first one, u is equal to 10 raised to x, log on both sides, log u is equal to log 10 x raised to x. So you have log u is equal to x raised to x, one function, and log 10 as another function. Now log 10 is a constant, so we keep as it is, differentiate x raised to x. Now in the previous question also we have studied how to differentiate x raised to x. So we get this as x raised to x 1 plus log x. Okay, then we substitute here. So we have 1 upon u du by dx, u gets shifted here, and what is u? 10 x raised to x. Okay, and hence we get this answer, which is the first equation. Now we take the second, sorry, this is the second one, v is equal to x raised to 10. So taking log on both sides, we have log v is equal to log of x raised to 10. So we get log v is equal to x raised to 10 is one function and log x is another function. So we apply product rule, x raised to 10 as it is, differentiate log x, then log x as it is, differentiate x raised to 10. So x raised to 10 as it is, derivative log x is 1 upon x plus 10x as it is, derivative of x raised to 10 is 10x raised to 9. So here x raised to 10 upon x becomes x raised to 9. So from these two terms we can take x raised to 9 common and shift v from left hand side to right hand side, and hence we get this dv by dx is equal to v x raised to 9 1 plus 10 log x, and replace v by x raised to 10. So we get a third equation. Okay, now next one, w is equal to x raised to 10 raised to x. Taking log on both sides, you have log w is equal to log of x raised to 10 raised to x. So 10 raised to x will come here, and we have log w is equal to 10 raised to x into log x. Now what we are doing, we are applying product rule, 10 raised to x derivative of log x plus log x derivative of 10 raised to x. Now you know this derivative of a raised to x is a raised to x into log a. So applying this, we get derivative of 10 raised to x as 10 raised to x log 10. Okay, now 1 upon w is on left hand side, it will come on right hand side, and then you replace it by x 10 raised to x. So we have this. Now in these two terms we have 10 raised to x common in both, so we remove it out, and hence we get a fourth equation. So what we are going to do, we are going to substitute second, third, fourth in the first equation, and hence we get this, the addition of 3. So this is second, this is third, and this is fourth, and this is a required answer. Question number 10, y is equal to cos x whole raised to x upon 1 plus x square. So what we do, we take log on both sides. So we have log y is equal to log of this. It implies log y is equal to log of cos x raised to x minus log of 1 plus x square. Now why it is minus? Because this term is in the denominator. Now we have log of cos x raised to x, so which we can write as x into log of cos x, and here we have log of 1 plus x square. Now derivative of log y is 1 upon y dy by dx. Here you have two functions, one function is x and second function is log of cos x, so we apply product rule. So we write x as it is. Derivative of log of cos x is 1 upon cos x, 1 upon cos x, and derivative of cos x is minus sin x, minus sin x. Then plus we write log of cos x as it is, log of cos x as it is, and derivative of x is 1. Okay, and now we differentiate this, log of 1 plus x square. So we have one function, and inside that we have one more function, 1 plus x square. So derivative of 1 is 0, x square is 2x, so we have minus 2x upon 1 plus x square. We have 1 plus x square. Okay, now what we do, y is on left hand side, we shift to right hand side, and hence we write our final answer. So we replace y by cos x raised to x upon 1 plus x square, and here you have minus x sin x upon cos x, that is tan x. We write tan x here, this is one term, tan x. Then second term we have log of cos x, it is log cos x, and third term we have 2x upon 1 plus x square, and hence we get a final answer. So you find logarithmic differentiation is actually very helpful to get the answer fast. Okay, so whenever you have function raised to function, or product of function, or division of many functions, you can apply logarithmic difference.